You think you know your garden. You planted for pollinators. You read the labels. You avoided the pesticides or tried to. And still, some summers the bees don't come, or they come once and don't come back. And you can't figure out why. The garden looks right. It felt like enough. But a bee doesn't see your garden the way you do. And what she's looking for isn't on any label you've read. Most people assume a pollinator garden is about the right plants, the right colors, the right blooms, the right season of interest. But the reality is that the plants are only the first gate. And most gardens that lose their bees permanently are failing somewhere else entirely. Somewhere most gardeners don't know to look. A bee entering your garden for the first time isn't browsing, she's auditing. She's measuring caloric return per flower visit against the energy cost of getting there. She's checking whether the soil she can see is the kind she can nest in. She's noting whether the stems from last year's growth are still standing or have been cut to the ground. She is building a case. And if the case doesn't clear a threshold that took millions of years to calibrate, she files it away and moves on. The window for that assessment is about 20 minutes. The consequences last the whole season. Welcome back to Bee Mind. Subscribe before you leave. What you're about to learn will change what you do with your garden this fall, before next spring even starts. Stay until the end. The third section is something researchers didn't think was possible. The last one is the part that changes everything. Number 1, what a bee is actually measuring when she enters your garden. Most people assume attraction is the whole story. A bee smells lavender, sees purple, and lands. If your garden has enough flowers, the bees will come, and if they don't come, you need more flowers. That is the model. It is also wrong. Not slightly wrong, not missing a detail, but wrong at the level of what bees are actually doing when they move through the world. A bee is not shopping, she is calculating. The research that clarified this came out of the University of Sussex over more than a decade of foraging studies, and what it showed is that a bee operates on an energy budget so tight that every flight decision is a margin calculation. Nectar has a caloric value. Flight has a caloric cost. The difference between them, the net energy return per flower visit, has to clear a threshold of roughly 10% surplus over flight cost, or the trip doesn't pay. A garden that looks full of blooms can fail this calculation entirely if the blooms are too sparse, too spread out, or too depleted by other visitors earlier in the day. From the outside, your garden looks like an offer. From the bee's perspective, it may not be one at all. This is why a bee can enter your garden, visit 3 or 4 flowers, and leave without returning. Not because something scared her, not because she found something better nearby, because your garden didn't clear the margin. The calculation ran, and the answer came back negative. What makes this harder is that the threshold isn't fixed. It shifts with air temperature because colder air costs more energy to fly through. It shifts with the time of day because flowers refill with nectar on different schedules, and a lavender plant that was rich at 8 in the morning may be almost empty by 11. A garden that passes the audit on a warm Tuesday morning may fail it on a cool Thursday afternoon with the same flowers open. The bee isn't being inconsistent. She's responding to real data your eye can't read. Picture it this way. You have a lavender patch at the edge of your garden. 3 plants, full of flowers, doing exactly what the label promised. A bumblebee finds it, works 2 flowers, pauses, works 1 more, and leaves. She didn't reject your lavender. She ran the numbers. The University of Sussex data suggests that most bees have a minimum patch threshold, a cluster size below which the density of reward per unit of search time doesn't clear the margin. For bumblebees visiting lavender, that threshold is roughly 9 plants in close proximity. 3 plants Even flowering plants often sits below it. What this tells you about your garden is this. The question isn't whether you have the right flowers, it's whether you have enough of them in one place to make the math work. A bee is not a visitor you attract. She is an auditor, and your garden either clears the threshold or it doesn't. Most yards don't know which side they're on. Now you do. But the caloric audit is only the first gate. What comes next is something even most experienced gardeners don't know exists. Number 2, the invisible infrastructure a bee is looking for before she commits. Most people think the flowers are the whole offer. Get the right blooms, get the right season, and you've done your part. The bee will handle the rest. But a bee assessing your garden isn't only looking at what's above ground. She's looking at what's below it, what's left standing from last year, and whether the space around your garden can support the part of her life you never see. Flowers are the menu. What she needs is the whole restaurant, including the kitchen and the place to sleep. Roughly 70% of native bee species nest in the ground, not in hives, not in hollow trees, in the soil itself. In small tunnels they excavate in bare or sparsely vegetated patches, typically in south-facing slopes or flat areas with loose, well-drained earth and minimal plant cover at the surface. The other 30% use hollow stems, the pithy centers of plants like elderberry and Joe Pye weed, old woodpecker holes, gaps in wood, or small cavities in stone. These are not exotic requirements. They are the conditions that existed in every garden before gardens became gardens, before we mulched, before we installed weed barrier, before we decided that bare soil was a problem to be solved. The USDA Agricultural Research Service has documented this in detail. A garden with rich floral resources but no accessible nesting substrate functions in practical terms as a commuter destination. Bees will travel to it from wherever they are nesting if it clears the foraging threshold, but they will not establish. They will not bring their reproductive cycle into your garden. They will not build the kind of multi-generational presence that turns a casual visit into a stable, year-round relationship. They will pass through, and when the season shifts, they will disappear, not because they left, but because they were never really there. Think about the mulched bed, the one at the front of most suburban gardens, weed barrier fabric pressed flat to the soil, 2 inches of dyed wood chips on top, edges clean, surface uniform. It looks complete. It looks like good gardening. To a ground-nesting bee, it is a sealed surface. She can hover over it. She can land on it. She cannot use it. The membrane underneath is impenetrable. The chips above it are too deep and too loose to excavate into, and the microclimate at the surface is wrong, too dry, too warm, too disturbed. She moves on. She was never going to stay. This isn't a fringe scenario. It is the standard configuration of the managed suburban garden, sold and installed and maintained by an industry that has no particular reason to tell you that its flagship product, the weed-suppressing, moisture-retaining, professionally installed mulch bed, is incompatible with the nesting requirements of most of the bee species you are trying to attract. What this tells you about your garden is this. The thing most sold to gardeners as essential maintenance may be the single most effective way to make your garden invisible to bees, not at the flower level, but at the level of whether the garden can support a bee's life, not just her lunch. A bee doesn't need a beautiful garden. She needs a functional one. And then there are the bees you never see, the ones who make the decision that determines whether any bees come back at all. Number 3. The scout bee, and the decision most gardeners never know is being made in their yard. Most people think of bees as interchangeable visitors. One bee is more or less like another, and if enough of them pass through, some will stay. But there's a structure underneath the foraging behavior that most gardeners never encounter, and once you understand it, every bee you see lands differently in your mind. Before a colony establishes a regular foraging route to any patch, it sends someone first. One bee, a scout. And what that scout does when she gets home determines everything that follows. Researchers believed for a long time that scouting was exploratory and essentially random. Bees fanning out from the hive in search of whatever was available, with no particular coordination before the fact. The work that changed this understanding came from the NIEH lab at UC San Diego, building on decades of dance language research, and what it showed is that scouting is not random at all. It is a sequential recruitment system with a quality filter built in. When a scout finds a patch, she evaluates it: forage density, nectar quality, distance from the hive. Then she returns and dances. The waggle dance is not simply a yes or a no. Its duration and vigor are directly proportional to the quality of the patch she found. A mediocre patch generates a short, low-energy dance. A high-quality patch generates a long, vigorous one. Other bees in the hive watch the dances being performed simultaneously by scouts from different patches and allocate their attention accordingly. The patch with the longest, most vigorous dance gets the most followers. A patch that fails to generate a competitive dance, even if the flowers are genuinely present and genuinely blooming, gets no followers at all. Here is what that means for your garden. If the scout who finds your lavender patch determines that the patch doesn't clear the quality threshold, too sparse, too depleted, wrong time of day, she will dance briefly or not at all. Other bees in the hive will not follow her. And because the colony's foraging attention is finite and is being allocated to other, better performing dances, your garden may simply never enter the system, not because it's bad, because the one bee who found it, on the one morning she found it, ran the numbers and came back with a weak report. That bee was in your garden for about 12 minutes, smaller than your thumbnail, moving faster than she looks, working the patch at the edge of the phacelia you planted last year, the one you almost didn't water through the dry spell in July. You may have seen her. You probably didn't register her as the thing she was. She was the audition. Every bee that follows, or doesn't, follows from her. What this tells you about your garden is this: there isn't a committee. There isn't a gradual accumulation of bee opinion. There is one scout, one assessment, one dance. Your garden's entire relationship with a colony for the season may hinge on whether a single bee found your patch on a good day or a bad one, at the right time of the morning or the wrong one, when your flowers were full, or when they'd already been worked down. That's not a reason to despair. It's a reason to understand what makes a scout's report strong. Number 4 is the part that changes the way you think about what you've been told to plant. Number 4, what the gardening industry sells that actively drives bees away, and why it keeps selling. Most people assume that the plants labeled pollinator-friendly at the garden center have been selected with pollinators in mind. The label says so. There's often a photograph of a bee on the tag. The display is in the section of the store dedicated to supporting wildlife. It feels like the right choice. But the selection process that determines which plants reach that display has almost nothing to do with what a bee can actually use, and quite a lot to do with what a human finds attractive from 3 feet away in a retail environment. Here's what happens when a breeder develops a new cultivar for the commercial garden market. They select for the traits that sell: larger flowers, more petals, longer bloom time, more intense or unusual color. These are the traits that catch a shopper's eye, that photograph well, that win awards at flower shows, and that justify a higher price point on the retail floor. They are also, frequently, the traits that make a flower functionally inaccessible or nutritionally empty for a bee. The mechanism is direct. The research documenting it came from the University of Vermont, Fry and colleagues working in 2013, and it compared bee visitation rates between standard open pollinated varieties of common garden plants and their double-flowered or heavily modified cultivars, echinacea, rudbeckia, sunflowers, the double-flowered versions. The ones with the fuller, more dramatic blooms showed near zero bee visitation compared to the open-pollinated originals. Not reduced visitation, near zero. The reason is structural. A double flower is a flower in which the reproductive structures, the stamens and pistils, which produce the pollen and nectar, have been partially or fully converted into additional petals. The flower looks more dramatic because it has more petals. It has more petals because the parts that produce what a bee needs have been redirected. A bee can land on a double cone flower. She just can't find anything inside it. She lands, investigates, and leaves. If she's the scout, she comes back with a short dance. Walk through the garden center this spring and look at the echinacea section. The cultivar on every label in every big box store, photographed with a bee on the packaging, is almost certainly a compact, double-flowered, or dramatically colored variety selected for human aesthetics. Beside it, if you look hard enough, you might find an open-pollinated purple coneflower in a plain 4-inch pot with a plain plastic label and no bee on the tag. That is the one. A bumblebee working an open-pollinated coneflower will stay on a single flower head for 40 seconds without moving on. The same bee on the cultivar beside it will land once and leave in under 5. What this tells you about your garden is this: the plants marketed to you as the solution may be the problem. The industry that benefits from selling you pollinator plants has not been optimizing for pollinators. It has been optimizing for your perception of pollinators, for the plants that look like what you imagine bees want, rather than what bees have spent millions of years actually needing. The plants that work rarely have a bee on the label. They don't photograph as well. I've saved this one for last because it belongs last. Not because it's the most dramatic, but because everything before it, the foraging calculation, the nesting substrate, the scout's report, the empty cultivar, all of it leads here to the moment itself, the one most gardeners never witness because they don't know what they're looking at when it happens. Researchers tracking individually marked bumblebee queens in suburban transects found something that shifted the way the field thinks about garden habitat. The average garden in the study was visited by bees on fewer than 11 days per season. 11. Not 11 per week. 11 for the whole year. But gardens that met all 3 habitat thresholds: forage density above the caloric margin, accessible nesting substrate within the garden footprint, and low disturbance through the winter and early spring, were visited on more than 80 days. Same suburb, same general landscape, same bees in the surrounding area. The difference wasn't luck or location. It was whether the garden passed the audit. There's a bee in your garden right now, or there was, or there will be, who has been coming back. Not every day, but reliably, the catmint in May. The same patch, the same time of morning, give or take. You may have stopped noticing her because she was always there. That's what establishment looks like. That's what it means when a garden passes. She assessed it. She danced about it. Others came. They confirmed her report. And quietly, without any announcement, your garden became part of a system. You did something right. You may not know exactly what it was. The moment the decision gets made doesn't look like a decision. It looks like this. Early April. Still cold enough in the morning that you can see your breath. A queen bumblebee. One bee, the only one, because the colony doesn't exist yet, she's it. Working the edge of a patch of ground in the corner of your yard that you didn't get around to mowing last fall. She's not foraging, she's investigating, moving slowly, hovering close to the surface. And then she stops hovering and starts digging. Small movements. Her front legs, then her middle legs. She's not foraging, she's excavating. That is the moment. That is what it looks like when a yard becomes home. Not the first bee on the first flower. The queen in the unmowed corner in April, finding the soil exposed and loose and south-facing, deciding this is where she will spend the next 4 months of her life building something from nothing. You don't have to do a great deal to get to that moment. Mostly, you have to stop doing things. Stop pulling the dead stems in fall. Those stems are where 30% of native bee species will overwinter or lay their eggs or simply take shelter during a cold snap in March. Stop laying the weed fabric. Stop replacing the open pollinated coneflower with the double-flowered cultivar that photographs better. Stop treating the bare patch in the corner as something to be fixed. That bare patch is the thing she's looking for. The gardeners who already do this, who leave the stems, who skip the fabric, who let one corner go a little wild, have been told they're being lazy, messy, not quite keeping up with the neighborhood. They're not lazy. They are, without knowing the mechanism, running exactly the habitat profile a scout bee is looking for. They were right. They just didn't have the language for why. Now you do. The bee from the beginning of this, the one circling the catmint, running her audit, hovering at the edge of the decision, you know now what she's calculating. You know the threshold she's trying to clear. You know what a passing garden looks like and what a failing one looks like. And you know that the difference between them is usually not what you plant, but what you stop removing. Your garden either clears the margin or it doesn't. You know which side of that line you're on, and if you're on the wrong side, you know exactly what to change. It's one unmowed corner. It's 9 lavender plants instead of 3. It's the plain coneflower in the 4-inch pot with the plain label. It's letting the yard be a little less controlled and a little more home. Tomorrow morning, before you do anything else in the garden, look at one bed. Count how many plants in it are open pollinated versus cultivar, and check whether the soil underneath your mulch is accessible or sealed. That is the audit. You now know what it means. Tell me in the comments, do you have a bee that comes back to the same spot every year? Same patch, same time of morning, like she never left? And have you ever watched one land on a flower? Spend a few seconds and then just leave and not come back. I want to know what that looked like to you, and whether it makes more sense now. If something in this made you think of someone trying to figure out why the bees won't stay, send it to them. The answer is almost certainly in here. I read every comment. I'll see you in the next one.